Yeah, so I'm going to talk a little bit about topic modelling some catalogue data from the National Archives this afternoon. The records of the General Board of Health in the record series 18, MH13, General Health's public health body, which existed to deal with public health in England and Wales from 1848 to 1871. Sort of basis I started from to a certain extent is that, so we talked a lot about born digital, digitized records today, but as sort of 19th century specialist, and not all the things I'm interested in are digitized. Digitization is, as we all know, very, very expensive. So often, because it's sometimes hard to get funding for such things, we as archive professionals do really detailed cataloguing, which is what is the case with MH13. And they're there to enhance human findability of records effectively. You put a keyword term into a catalogue, in this case Discovery, National Archives catalogue, and you get return more results if you have a detailed catalogue entry, which directs sort of a user in that sort of positive act of accessing the archive that John was talking about to get into those records. They realise it's relevant to them. But I'm sort of looking at what we can use machine learning to sort of distant read these catalogue entries and better inform as researchers our record selections and indeed our close readings of those records that the catalogue represents. So I'm going to do a little bit of historical background first about the material I'm dealing with. And it all relates to cholera and the Public Health Act 1848, effectively. So as I'm sure we all know, there are quite a few cholera pandemics throughout the 19th century across the globe, as is implied by the word pandemic. And governments take action to try and deal with them, which I'm sure by after the last 18 months or so, we're all aware of such things. So England's first hit by cholera in 1831 to 1832 kills about 52,000 people. The government set up a short-lived temporary body called the Central Board of Health to try and deal with it, which was relatively unprecedented for English government at the time. Then it slumbers as the pandemic sort of recedes from the British Isles. In 1848, there was another large outbreak of cholera in the British Isles, in England and Wales, over that sort of 1848, the winter 1848, 1849. It kills over 53,000 people. As a result of this, the government passes the Public Health Act 1848, which is a landmark piece of public health legislation in Britain and indeed across the world, I would suggest. It sets up a General Board of Health, which is a government department based in Whitehall, which oversees throughout its periods over 1,000 local boards of health, sort of local instruments of local government to deal with public health and sanitation, amongst other things. The records of the local General Board of Health, its correspondence with local boards of health, other local officials, doctors, members of the public, people complaining about how the Public Health Act is centralisation and too expensive, as you can see from a couple of anti-public health posters on the screen there, are in the record series at the National Archives called MH13. This record series consists of 272 bound volumes of correspondence. There are some 89,000 individual items of correspondence within the records. And we know this because from 2013 until about 2018, 2019, we had some money from the Wellcome Trust to catalogue each item of correspondence. So ideally, basically what came in an envelope to a certain extent in detail, which is what I've been working with. As I've said before, these entries are designed to be keyword search effectively. They're there to sort of shout to readers when they put a keyword into the catalogue, cholera or nuisance or something like that, that, you know, these records are here, come and read them. They're to drive people into the archive. I'll just give you an example of what the descriptions look like. So we can see here as a sort of standard description. So I highlighted the different information you find in an item description for a piece of MH13, but missing the reference. They each have an individual reference. It's MH13, then a number for the volume, the physical volume, and then a number for the item within that. And then you have this. So you get a folio range, which is the internal reference. You get who the letter's to, often to the General Board of Health, because they're the ones receiving most of the correspondence, who the letter is from, that ranges massively. And then finally, in the black text there on the screen, you can see the description of what the letter is about. And they range in detail from, you know, sort of 20 or 30 words there to several hundred words in some cases. And, you know, these are what I think in archival theory we would call the representation of the record. And they're there initially, their original purpose is to drive people to come and look at the material itself. But what about if we use the catalogue as opposed to the record itself as data? So obviously, I know we've been speaking a lot about the fact that, we as archives have lots of data. Whether stuff was created to be data which was going to be manipulated through computational means is a different story, but we've come to the realization that we have to sort of make that possible and look at the risks around that. And that's obviously the basis of the 2017 Santa Barbara statement on collections as data, which I'm sure many of you are aware of. But I also wanted to think about if we take this a step further to a certain extent and seek to use the data we create about collections, our catalogues, our indexes, our finding aids, in a similar way to what we'd use the original records. And what could we do with these vast amounts of machine-readable texts? So that's sort of the basis I'm trying to do, and I wanted to do some distant reading. So if you're not aware of the term distant reading, it was coined by Franco Moretti in the New Left Review in 2001. So effectively he was saying to study literature, there's too much literature. We can't just do a close reading, that traditional way of looking at a text and analysing it in a sort of very close particular way. We have to use a machine to read it from a distance. So we read a large corpus of text and then we analyse them by mapping them, by tabulating them, by putting them into graphs, otherwise visualising them. And that sort of stands in contrast to traditional close reading. The Google Ngram viewer is a great example of this. It allows you to analyse the frequency of terms or bigrams across a very large corpus of digitized books and see how they sort of vary and wax and wane over time. So there's just an example there of cholera and plague, which see there's a sort of spike in interest in cholera around the mid-19th century English books, which coincides with cholera outbreaks as plague begins to decline as well. So that's one way of doing it, but I decided to carry out some topic modeling, which is effectively using machine learning to take a corpus of text and say, how do you want to group these things together? What terms allows us to understand these groupings within the text? What are these things about? Tell me, without sort of pre-warning it what they might be about. So one form of topic modeling is term frequency inverse document frequency. It's quite a simple one. So effectively, it works on the assumption that if a term is frequent within an individual text within a corpus of text, but that word is not so frequent across the entire corpus, so it has an inverse document frequency to its text frequency, we should therefore consider that word to be important to that text and tell us about what it's about. And that avoids you from having a machine learning algorithm telling you that the most important word is the, because that is common in every text across an English language corpus, undoubtedly, because it's a connected word, whereas, for instance, cholera may not be common across the rest of the corpus, so we'll say, oh, this document's about cholera. But the method I've decided to pursue is latent Dirichlet allocation, which I call LDA to avoid having to pronounce a French surname regularly. So LDA works under the assumption that each text has a latent or underlying topic characterized by a distribution of words within it and across the corpus of other documents. All the user does to a certain extent is define the extent of the corpus and the number of topics they want to emerge, say 5, for instance, K number of topics, we could say. The model then calculates, using sort of Bayesian probability calculations, the relationships between each of the words and the texts within the corpus, and then groups, make grouping of topics, of documents and words as a result. So to begin with, I took a test corpus of all the catalogue descriptions of MH13, dated 1848, the first year of the General Board's operation, and began doing some cleaning on it, which I will talk about briefly. So you can see on the left there is the text as you download it from Discovery in a CSV file, so you get a citable reference, and then a description, which contains all those internal reference, the to, the from, and the subject matter I was talking about earlier. I then wrote some really, really shonky code to find what you have on the right. So you separate out the to, the from, and the description. There is some absolutely atrocious Python code, which I will not dwell on because I'm not proud of it. This allowed me to just have the text for the description as opposed to and from, to not try and have too much noise or confusion in the topic modeling, to just model those descriptions of the letters. I then went about modeling this in LDA using the Python libraries Gensim, which is great for all forms of topic modeling, and PyLDA Viz, which I saw a screenshot of in an earlier paper. It's another fantastic library for visualizing LDA topic models, because they can be a bit difficult to interpret to the human eye to a certain extent. So let's take a look at the 1848 model, which is a YouTube video, and I really hope it works, but there's no sound, so it should be all right. And I will try and describe the topics as I go, because they might be a bit hard to interpret. There we go. So we start with an overview of all the topics across the salient terms across the entire corpus. You see there's a map there on the left, which gives you the location of the topics, their size. This is the first topic that relates to local authorities asking about their sanitary powers if they adopt the Public Health Act. The second one relates quite closely. You can see it's very close on the map. That's about powers under an earlier piece of legislation called the Nuisances Removal Act. 3 is another topic related to the first one. It's about the adoption of the Public Health Act in localities. Number 4, these are quite distantly related. These are reports of cholera cases and other medical outbreaks in localities. And number 5 is a very distinct topic. It's very far on the left-hand distance map, which shows the relation of topics. That's about engineers applying to be superintending inspectors to the General Board of Health, because it just opened. So very quick overview. Sorry, it's a short paper. I can share some blogs and stuff with people afterwards and my slides if they would like to see them. And we're going to discuss what these topics mean and how successful this work is in a minute, but I've subsequently done some extra work in the last couple of days, actually. I was sort of motivated by this paper to look at doing the entire data set, all 89,000 or so catalogue entries for MH13. So I've been working with pandas, this is sort of boring technical stuff, and using GenSim again, to work with, after some cleaning, I've ended up with about 88,899 catalogue entries. Had lost a couple due to some weird problems with regex and splitting, which I plan to correct in the near future. But you can see a representation of what the data set we have there. So we have the title reference, still the dates, who the letter's to, who it's from, then that separate description field, which is what we actually model. And then you can basically, those of you who've done topic modeling before, you basically vectorize words and make them into a bag of words. So you create a list of the lemmatized, sort of shortened, taken back to their root words, which you can add into the data set. And then you can add lots of other things on as well, but I don't really have time to go into that. And again, use GenSim to model it, and this time sort of set an arbitrary number of 15 topics. Now, I was going to try and visualize this with PyLDA Viz, but I'm currently having massive problems getting it to work in Google Colabs, which apparently is a pretty common thing. And because of civil service computers, I can't install it on my laptop. So there'll be no visualizations this time, but I thought I'd give you a quick overview of the topics that were produced when I called them up in sort of my own quite shonky visualization. So we can see here 14 topics, and I'm not going to go through them one by one because we do not have time, but effectively what I've done here is you have in the left-hand column the topic number, so ranging from 0 to 14. Then you have the top 10 keywords as produced by the model in each of those topics, and then you have in the right-hand column an interpretation, which I have written of them because I know the material, and otherwise if you don't know the material, then these words probably won't make a lot of sense to you. They are quite similar in their subject areas to the 1848 modelling of the 2,000 entries for that year, which is encouraging to me. And gone as a topic for employment applications, but I think that actually is a very small, discrete part of the data set as entirety. It figures quite significantly in the very small sample of the 1848 stuff, but people only actually really apply for jobs, from my knowledge of the material, in the first year en masse. So it's not surprising that it doesn't really survive. And then again, you have basically subdivisions of the stuff we were looking at with the first 2,000 entries. We have 5 topics. We have lots of queries about the adoption of the Public Health Act and the Local Government Act, its successor to localities, medical reports, complaints of nuisances, queries as to power under laws, and applications to get a sanction to borrow money as a local authority to carry out improvement works, whether that be on roads or sewers, as well as a reprise. So I suppose the question is this useful? Is this gobbledygook? How do we evaluate what we're doing here? So I've got a couple of suggestions in that sense. So one, trust me on this, the eyeball testing. Does it make sense to someone like myself who knows the material that we're trying to model? As far as I can work out, there's not much point topic modeling stuff that you don't know anything about, because it won't give you interesting results. So in this case, it passes the eyeball test, I think. But you can also use other machine learning methods to try and get an idea of how useful this is. So I've been calculating coherence scores for this model. So I've been using a CV score, which basically looks at rates the coherence of model by how often, on average, words within a topic coexist in the same document across the entire corpus. 0 means they don't coexist at all, which is bad. 1 means they always coexist together, which is also bad because it means it's like overfitting or something wrong. My model with 15 topics has a coherence score of 0.56, which is okay, but it could be better. I'm planning to basically do a lot of testing across a whole range of number of topics to see if I can get a more coherent model, but it takes forever with this many rows of data, so I haven't managed to do it for this. I'm aware that I'm over time, so I'll finish up now. So I suppose the question is, has this told me anything new? In some ways, no. I wasn't surprised by the topics that emerged from this. I catalogued a significant number of them myself. I know the material very well. But the fact that they match up with what I expected to find means that hopefully the topic models are relatively coherent. What I hope to do is help to sort of inform some close reading of my own research into these records using the topic models, and using this catalogue as data as a way to sort of give me a macro picture before I go into the micro picture. But I shall finish up now. Thank you very much.